Okay, we're starting a new unit today, and in Unit 4 it's all about triangles, and in 4-1 the topic is classifying triangles. Alright, so let's start by looking at a triangle. Well, a triangle has 6 parts. It's got 3 sides, okay, and it's got 3 angles. Okay, so a triangle has 6 parts all together, 3 sides, 3 angles. And so now we can start looking at the notation of how to name a triangle. And first of all, you will use the triangle symbol as denoted here, right? And you will use the 3 vertex points, okay, as the letters. So you'd use the letters of those vertex points in order to name your triangle. So like, for example, this triangle could be called triangle ABC. Alright, so triangle symbol and then the 3 letters of the vertices is how you would correctly name it. Now, the order of the letters doesn't matter, and so this one's got 6 different ways that it can be named. It can be triangle ABC, triangle CAB, triangle BAC, triangle BCA, and then you get the idea. Alright, so there's 6 different combinations that could be used here to name this triangle, and they're all a correct way to name it. Okay. Now let's go ahead and list out the 3 parts, or excuse me, the 6 parts here. So we've got 3 sides. Well, remember, a side of a triangle is a segment. Like, for example, this segment right here is segment AB. That is the left side of the triangle. Alright, segment BC, that's the right side of the triangle, and segment AC, that is the bottom side of the triangle. Okay? Alright. And of course your 3 angles, there's an angle at each vertex. So angle A is one of the angles, angle B is another one, and angle C is the 3rd angle. Now, remember what we said all the way back in Unit 1, right? How do I name the angles? Typically you would use 3 letters. So if I wanted to name angle A right here, I would use angle BAC, which is still correct, but since that angle A is the only one that's coming out of this vertex, we can get away with the 1 letter. Angle A means this angle right here. Why? Because there's no other angle coming out of vertex A. If there was, you'd have to use the 3 letters. Okay? But remember, if there's only 1 angle coming out of that vertex, then you can get away with just the 1 letter. Okay, so the next thing we're going to look at is a chart that classifies the triangles by angles and by sides. Okay, so classification by angles looks like this. An acute triangle, okay, is a triangle with 3 acute angles. Right, 3 acute angles. So if it's got 3 acute angles, then it's known as an acute triangle. Now, a right triangle is a triangle that has 1 right angle. 1 right angle. Alright? So, you might be asking yourself, well, why just 1 right angle? How come it's 3 acute angles for an acute triangle, and then not 3 right angles for a right triangle? Well, think about it. If you try to make 3 right angles, alright, so like here's 1 right here. There's a right angle. Okay, but the problem is, if I were to make another right angle out of, let's see if I got something here. Okay. If I were to make another right angle here, then look at what happens. Okay, that's already all 3 sides, and it cannot close. Okay, so a triangle can have at most 1 right angle in it, and at most 1 obtuse angle, more than 90. And so that brings us to this next term, obtuse triangle. It's a triangle with 1 obtuse angle in it. Okay, and so these are the descriptions for the triangles that are named by angles. Okay, we also can classify the triangles by sides, which is the other column of this chart. First of all, we have a scalene triangle where all sides are different. Okay, we have an isosceles triangle where 2 sides are the same. 2 sides are the same. And we've got an equilateral where all sides are the same. Now, if all of the sides are the same, then that actually forces all the angles to also be the same, and that's called equiangular, right? So an equilateral triangle is also an equiangular triangle. So again, scalene, all the sides are different. Isosceles, two sides are the same. And equilateral, all sides are the same. And so now what we want to do is we want to practice classifying these triangles. All right, so based on what we see here, we want to classify this triangle by the angles. All right, and so if I look here and I see a right angle, then that is a clue to me that this is a right triangle. All right, right triangle. Okay, next one. Remember, these marks mean that all three of these angles are the same. And if all three of these angles are the same, there's only one thing that they can be and still add up to 180. All right, so when you're looking at this, we've got to say that if all of these are the same, then you've really got yourself an equilateral triangle. And in an equilateral triangle, then we know that all these angles are going to be 60, 60, and 60. All right? And so what kind of a triangle is it? It's an acute triangle. All right, so for the next one now, we've got 120, 30, and 30. And so since we're classifying by angles here, we have one obtuse angle, so that's going to be an obtuse triangle. Okay. All right, so the next one is going to be classification by sides. Okay, so the first one that we come to here, 5, 5, and 5, okay, they're all the same. It's also obviously going to be an equilateral triangle. Why? Because all 5 sides are the same. All right, equilateral triangle there. All the sides are the same. What about the next one? 8, 10, and 2. Well, all the sides are different here, and so if all the sides are different, what's it called? Scalene. Alright. Okay, so in this one we've got a congruent mark here and here, so that indicates that these two sides are the same. Doesn't necessarily mean the third side is the same, but we do know two sides are the same, and if at least two sides are the same length, it's an isosceles triangle. Okay. Alright. Okay, so in this next diagram we have several triangles, and we have different tasks that we're asked about this particular diagram. So the first question that we come to, it asks us to name an acute triangle. Name an acute triangle, a triangle that all of the angles are less than 90. Alright, so one that stands out to me here is this triangle, where there's one mark in each spot here, and what that means is that all those sides are the same length, and so my triangle here, if all these sides are the same length, then all the angles across from them would be the same, and there's only one thing that they could be. It's got to be 60, 60, and 60. And so if that's the case, then there's no angle above 90 degrees. So I'm going to say that triangle let's see, triangle, can name it several different ways, remember. DBC is fine. So triangle DBC, we know, is an acute triangle. Once again, many different ways to name it. Okay. Just as long as we write one of those correct ways, we should be in good shape. Okay. The next one that they're asking me for is to name a right triangle. Name a right triangle. So a right triangle should have 90 degrees as one of its angles. This one up top does. There's a 90 degree there. And so if I wanted to name that triangle, if I wanted to name that triangle, I could say that that's triangle ABE. ABE is the correct answer. Okay, the next one, name an obtuse triangle, one where the angle is more than 90. And so since this is a linear pair, if this is going to be 60, then this is going to have to be 120. And so we know that 120 is more than 90. And so I'm going to name this triangle as my obtuse triangle. And we'll call it triangle EBD. Triangle EBD. Okay. So now we shift gears and attempt to classify triangles on here by their sides instead of their angles. And so we've got name a scalene triangle. Now, don't forget what the definition of scalene triangle is. It's going to be that all of the sides are the same. And so when we're looking at this, I just said that wrong. So scalene triangle is one where all the sides are going to be different. All right, all the sides are going to be different. Scalene triangle. And so when I'm looking for a scalene triangle in this diagram where all of the angles are different, of course it can't be that one because all the sides are the same there. It can't be this one because two of them are the same. However, in this one, I've got one mark here, two marks here, indicating that those two are going to be different. And so also, if that's the case, if we had numbers here and utilized the Pythagorean theorem, then we see even that third side would be a different length side. And so I think that we should write down as our scalene triangle, ABE. Alright. Okay. Alright, next one, name an isosceles triangle. Okay, that's going to be a triangle where at least two sides are the same length. And so I see one mark here, and then that to me indicates, excuse me, can't see it, one mark here and one mark here, and that's going to indicate that these two angles across from these are going to also be the same. And so, like when you're looking at this though, an isosceles triangle is one where two sides are the same, and so this is the triangle that I can name. So we'll call it triangle EBD. Alright, EBD. Okay, and the last one is to name an equilateral triangle. All sides are the same. That'll be this one, triangle DBC. Alright, and so pretty much if we just know these 6 definitions, then we should do fine on the quiz. Acute, right, obtuse, scalene, isosceles, and equilateral.